Welcome to our webinar on how to get great performance from your network. I'm Zoe Buckingham, Head of Marketing at Application Performance. Our webinar features network expert Cliff Chapman, who will demonstrate a new and unique system of monitoring, diagnosing, and reporting the performance of end-to-end network paths. On your control panel, you will see that you have a question box. You can use the question box to send Cliff questions throughout his presentation. Cliff will do his best to answer your questions at the end. Thank you for listening, and now I'm very pleased to welcome Cliff Chapman to begin his talk. Thank you, Cliff.
Thanks, Zoe, and hi to everybody. Thanks for giving us some of your time. As Zoe said, we'll be looking at a unique network performance management system. It's only been available outside the US for a few years, but actually has a 12-year maturity inside the US. So let's dive straight in. Everyone loves to blame the network for problems, and probably because in the past it's been so poorly equipped with tools to refute the claims. But essentially, when the network is at fault, there's only two simple things that can go wrong. Bits of it are broken, or bits of it are too small for the job. And Neptuna will find the broken bits and the bits that are too small. But before we see the new approach, let's just briefly remind ourselves on the traditional way. Typically, people use SNMP, or they try to monitor the traffic load, and sometimes lots of lucky people have got both. But the problem is that neither of those ways of looking at the system can provide an end-to-end view, and that's what you really need if you're looking at the application performance, and particularly from a user perspective. Neither can differentiate between what's actually going on and what should be going on, or what could be going on. And certainly neither are reliable for first indicators of performance degradation. And of course, you can't use either of those methods if you don't own or manage the network, or parts of it. So I like quotations, and these two really say it all for me. So from Albert Einstein, many of the things that you can count don't count, and that's really true for SNMP. SNMP counts a whole pile of things about each device, but none of them really have a direct or unambiguous relationship with application performance. So we need something that counts what really counts, in Einstein's words. And the second one, the perfection of means and confusion of ends, seems to characterize our age. Again, that's true. We have thousands of ways of really cleverly doing things, but sometimes we get a bit lost about the end result of what we're trying to get to. So I'm not saying that SNMP and traffic monitoring are totally useless. They're just hopeless as first indicators of network performance degradation. And once we have a system that can point us exactly where the problem is, then SNMP and traffic monitoring are really good techniques to apply to them. So we're going to spend the next 20 minutes just looking at this brand new way of monitoring and managing network performance. And a good quote to kick us off from Bertrand Russell: it's just take 20 minutes to hang that question mark on the way we do things right now, and just take a look to see if there might be a better way. So Neptuna is, you consider it a real user of the network, and that's where the system really stands out from all of the other systems, because we're not looking at devices and we're not receiving signals from instrumentation. We're actually using the network. And that's what makes this thing completely different. We're using the network, and we're probing the network with a special technique. So our probing traffic is experiencing everything that an application traffic flow would experience. So the basic building block for Neptuna is the concept of a path. So let's see what a path means. So we're always looking at end-to-end connectivity, because we want to see the entire network between the user and the application service. So a path is any end-to-end network connectivity path, and it doesn't matter what the media is. It can be wired or wireless or optical, and can be mobile. And we have a probe at one end, typically a dedicated hardware appliance, and any networking device at the other end, so anything that we can reach with an IP address. We have good targets, which are typically servers and PCs and laptops, and they're always the preferred target. So as long as there's something that's always on at the other end, that's what we use. If we have to, we can use routers and switches and other oddball bits of networking kit, but we don't really like to do that because they're not reliable responders for the probe. And these probes, these network paths can be across a gigabit, 10 gigabit data center backbone, or they could be halfway around the world or all the way around the world. The technique that Neptuna uses to establish the characteristics of the path is not affected by round trip time or latency as many other measurement techniques are. So we're actively probing each network path, but it's a special technique called packet train dispersion, which uses particularly spaced bursts of ICMP, and it looks at the distortion in the compared to the outgoing timing when it returns back, when it's been echoed back. And from analysing those differences, we can see all sorts of aspects and characteristics that are really important about the network. So, as Einstein said, it's measuring the things that count are the most important thing, and that's what we do. So we can see capacity, and that's total capacity end to end. I don't know of another product that can give you a very accurate view of the total capacity or the total throughput that you've got end to end. Utilization levels and a whole pile of other stuff that you must know about in order to understand how well that network path can support application performance through it. So once we've established all of those characteristics, we can build a service level objective around the characteristics of the path. So each path carries with it its own service level objective. So that means you no longer have to worry about whether 10 milliseconds is a really good round trip time or a very poor round trip time, because once the path's been set up, we establish service level objectives that are uniquely associated with that path. So as we report upwards, we no longer care about the absolute measurements of these things, we just care that the service level objective is met. So as I said, the path is the basic building block. So we can move downwards, we can drill down on a single path, and I'll show you a picture of the diagnostics across a single path. And we can also combine paths so that we can build upwards for more management style reporting. So the basic architecture of Neptuna, as I mentioned, it has a probe, a minimum it has one probe, and it just requires reachable IP addresses at the end of the path it's monitoring. Now, we can have a probe as the other end, so the probe, another probe could be the target, and if we do have paths with probes at each end, we're able to do some slightly more sophisticated testing with that. But essentially we get really great results just from using an IP address. It's software as a service, so the probes summarize and perform most of the analytics on the data, and that information is summarized and sent up securely to the cloud service, and we just log on with a browser to manage the whole system. So nothing special for the internet connection, it just needs outgoing connections on HTTP and HTTPS. So the system is extremely easy to manage, and I often manage the whole thing just from an iPad. It works extremely well. This is a view of a single path. So this shows us some of the more basic characteristics of the path. So this is the top blue area is the total capacity. So you can see there's a yellow line that runs across the top, and this is the line that either has been manually set because we know the link to be a certain size, or it's Neptuna's assessment of what the true capacity of that link is. And you can see that in this particular example, the upper blue shaded area doesn't adhere completely to the yellow line, and this is another unique aspect of Neptuna. So what we're seeing here is the total capacity, which is the lighter blue area, and the darker blue area is the utilization levels on that path. And remember, whenever we look at these things, we're talking about the characteristics of the end-to-end path. So the utilization is end-to-end. So the traffic that's causing the high levels of utilization could be at any part on the network, but it's important to remember that it's actually present on the path, so it would be experienced by applications that were on that path too. The smaller graphs show us packet loss, jitter, latency, and round trip time, and you can see that the black horizontal marks, the horizontal lines, they indicate where we've applied a service level objective for a particular characteristic. So each of the characteristics that are monitored can have their own SLO, and each SLO can completely be customized for each path. So you can see in the bottom right area, the round trip time has exceeded the SLO for a couple of times, and you can see on the upper graph the red diamonds, and they indicate the point in time where any of the SLOs have been violated. And then there's two important things that happen when an SLO is violated. First, you can opt for a notification if you want to. You may not want notification, but more importantly, whenever an SLO is violated, that path moves into a deep diagnostic phase. And all of the characteristics that were being measured end-to-end will now be measured at every hop. So we will be able to see where the round trip time suddenly extended. We will know which hop suddenly contributed a whole load more delay. So that's what the view of a single path looks like, and typically you're only interested in this view in the early days when you're trying to establish what the path looks like so that you can build service level objectives, or if you're doing some troubleshooting and you want to see what it is. So it will take a look at what the diagnostics look like. From this example, you can see that diagnostics takes the form of a table. The top of the table is the position of the probe, and the bottom of the table is the position of the target. And on this particular example, we can see that at hop 3, there's data loss has occurred. So the problem for this path was we had a service level objective around data loss because we knew the path to be a problem path. And the problem was periodic, so it was difficult to capture. So we set fairly tight SLOs on it to capture diagnostics every time there was packet loss. So we discovered quite quickly that the packet loss was always generated at hop 3. So we knew the IP address, we knew who owned that device, so we could focus our attention completely on that device. So as with packet loss, once you have packet loss in an end-to-end path, the effect of the packet loss gets propagated all the way down the line. So the point we're looking for in this diagnostics is the device where the packet loss is first experienced. And coincidentally on this, you can see over to the right-hand side here, we're able to tag the probe traffic with QoS values so that the probe traffic itself can be handled specially by any QoS schemes that you have running. So for example, we could have a probe that was marked in the same way as voice and video, so that we could be looking at very specific paths through the network and how they're handled. And we found that at hop 4, the device was stripping the quality of service marking from the probe as well. So we sort of found two problems at the same time, but the one we were looking for was the packet loss. So you can see here these are all the characteristics that we were graphing here, and now we get each of these characteristics hop by hop. So really detailed and more importantly, a very timely set of diagnostic information for precisely the time that the problem exists. So that's drilling downwards into a single path. The next thing we want to do is to be able to group paths together in a meaningful way that enables the paths to represent a service, if you like, because we want to make the whole system as useful as possible. So if we imagine this very simple schematic, we've got some WAN paths being probed, we've got some LAN paths, we're across a VPN on an internet, and we've actually got targets in the internet itself so that we can establish how the quality of the internet connection. So a collection of paths like this is okay, but it would be more interesting if we could bundle a whole set of paths together that were associated with particular applications. And so as an example that we're going to show this now, so let's say for HR, just the heavy blue paths are the only paths that are associated with the HR applications. So everybody who runs HR lives in the bottom WAN branch, and the other branches don't have any interest in HR. But obviously the LAN path to the HR servers and the DNS server are essential parts of the HR application, as is connections out to the internet. So we can now see that we can group these paths together, and we can call these paths the HR service, so that if any of the path fails and it's a member of a particular grouping, we can immediately see the services that are being disrupted because of a path that's associated with that service having a problem. So another example is a service path for an ERP. So essentially the only thing that's not included is HR. And there's no limit to the number of service groups that you can have for this system. And each path can be a member of multiple service groups. So because the performance, when we move up from the individual path, and we've moved away from diagnostics, because we're no longer interested in the absolute round trip time or the absolute level of packet loss, we can base all of our reporting on service level compliance to the objectives that we've set, because each path already has its own definition of acceptable performance. So when we report on the performance, we can get an overall view of the level of compliance with the service level objectives, and a breakdown of each violation type. So we can see typically we have lots of connectivity problems, but we also have some packet loss problems, and we also have some round trip time problems. And the report will break out the worst performing paths per service group, so that you can really focus on the problem paths. So as an example of what this looks like on the portal, this is the type of view that you get for each service group and for all service groups combined. So the way this is configured on the portal is you put paths into the appropriate service groups, and then you just tell this report to give you a report on all of the service groups. So it will automatically do a total overview by adding all the paths together and saying, well, here's the global overview of service level compliance, and then it will break down a report that looks just like this for each one of the service groups. So for every service group you have a picture of its overall compliance, and for each group you will have the worst offending paths that are causing a lack of compliance, and the type of problems that path has. And from this view, if you're live on the portal, you'll be able to drill right down to the actual path and take a look at recent or historic diagnostics to work out what the problem is with that path. So another view of this is the violation breakdown. So this gives you a picture of all the sorts of problems that you have on the network. And for each type of problem, it will give you the worst offending path. And another way of viewing a similar picture for this is we can look at the top offenders for the number of violations that they've had, which is the top view, and the top offenders by the duration, the total duration of the violations that they've had too. So that's really a picture of the system. It does a whole lot more. It has more modules, but we wanted to really focus on the differences, the big differentiators between network performance management using this actively probed system compared with SNMP. So to really summarize the whole thing, if you look on Neptuna as being a real network user, and that's the key to it really, because the network is actually being exercised by Neptuna. So the probe traffic gets to experience all the same problems as application traffic does. And the way that the system is set up for this packet train dispersion, you also get a good picture of, for example, are small packets being handled differently to large packets. So even without some of the more sophisticated modules for voice-specific and video-specific traffic, you will actually, on the diagnostics, you will actually see comments that say small packets are not being handled consistently in the way that large packets are, or the other way around. And also we will be analysing traffic paths or paths for lots of other more technically oriented aspects and characteristics. Like we'll be looking at the MTU size, and is the MTU size consistent over the entire path, and are there any indications of NIC duplex mismatches. So there's lots of things that the path analytics is doing that can't really be graphed, but they get exposed in the diagnostics. So we can see how we can use the concept of a single path or groups of paths. So the path itself is the building block. We can drill down for diagnostics on problem paths. And use the inbuilt service level objectives for each path to enable us to group paths and simply report on their service level compliance. Or right at the very top end, we can get a view of the entire infrastructure just on one page and its level of compliance to its service level objectives. The whole system scales really well. You can use a handful of paths, or you can literally have thousands of paths. And because the reporting system essentially focuses in on the worst offenders all the time, you can gradually build a networking system where you deal with the most significant problems first, and then as they get dealt with, the next most significant surface, and you can deal with those as well. So I've been using the system for 5 years, really since it was available outside of the US, and it's a complete joy to use. It's really easy to get it installed. Typically we supply pre-configured probes, so it just goes in, gets plugged into a network port. It needs internet access. As soon as it powers up and boots, it registers itself with the cloud service, and from that point you can be up and running with paths within 10 or 15 minutes, getting useful information from it. So it's, as Henry Ford says there, it's one of those things that everybody always seems to be looking for the next best thing, and it's probably no surprise that SNMP is typically such a disappointing outcome for people, and but I think the mistake is to keep on looking for another SNMP monitor that may do a bit better than the previous SNMP monitor that you used to have. And the time that this system can save with its automatically triggered diagnostics and its ability to really keep a continuous view on the network, there is nothing else like it, and I'm a big personal fan of it, as you can probably tell. So that's really my summary. I've tried to keep it as short as I could. I'm really grateful that people were able to give up some time to hear about this. And if anybody's got any questions, I'd be more than happy to take them.
Thank you, Cliff, for an excellent presentation and a great guide to a new way to monitoring your network. We have received some interesting questions, and I'd like to put these forward, and please feel free to add these in the question box on your panel. One of the questions that we've had, Cliff, is sometimes you mention network performance and other times application performance. Which one do you mean?
Yeah, it's what we're trying to do here is establish the ability of a network infrastructure to support, to fully support high-performing applications. So the system really is for network performance. So what we're looking for the system to tell us is that things like round trip time are stable and appropriate for the physical distance of the link, and the capacity of a particular path is as we would expect it to be from the specifications of the equipment. So if the WAN provider has given you a 20 meg link, you expect to see a minimum of 20 meg across that path. So what Neptuna will do will establish effectively that the network infrastructure is operating completely to specification and it has no problems. Over and above that, you can't expect the network to provide any additional improvements to application performance. So yes, sometimes I mention application performance because the end point that we want to get to is to have provisioned a network that is competent to run the applications that we want to run across it. So ultimately, the only really important thing is application performance. But the system is all about network performance. But going back to Einstein's quote about means and ends, a network is not an end in its own right. A network is a means, and the thing that's the end is the application performance. So in some ways, maybe I use them a bit too mixed up, but I think if you look at it, what this does is really eliminates the network as being contributor to application performance, or can spot what it is about the network that's causing application performance problems. So I hope that clears that up.
It does. Thank you very much. Well, certainly for me anyway. I hope for the rest of the audience. And another question that we've had in is, how do I know that a realistic service level objective has been applied to a path?
Well, as I said before, you have to look at the characteristics that you measure. So we don't put service level objectives on a path until it's been up and running for, let's say, at least a few hours or a day. And then we have to know what that path represents. So if that path is a national WAN path, but it has a round trip time of 300 milliseconds, there's something wrong there. So you have to apply a little bit of common sense and think, okay, well that can't be right. There must be something wrong there. A national WAN should be around 5, 10, 15 milliseconds, something like that. So you know straight away there's something wrong. So at that point, I would probably manually trigger a diagnostic run to find out what the round trip time numbers were hop by hop across that link, because there's obviously something wrong. Again, if you see a WAN capacity of 2 meg, but your contract with your provider says 20 meg, then there's something wrong there too, so you need to find out what that is. But if everything looks okay, if the round trip time and the latencies are pretty much what you'd expect for the physical distance between the endpoints of the path, and if the capacity is okay and there's not too much packet loss. So packet loss, you'd expect pretty much zero packet loss on an MPLS WAN, but if you've got an internet VPN, you may have to put up with a few percent of packet loss. So you look at what you're getting, decide common sense wise if it's more or less there, and then you apply the surface level objectives. I have two stages for surface level objectives. The first stage is I use very tight surface level objectives because early on, if there is a problem, I want it to trigger diagnostics as many times as possible to get a really good picture of what's going on. Now, once we know what's going on, we may want to loosen the SLOs on paths because we don't want too many notifications, and we only really want notifications, and we only really want diagnostics run when it looks like the problem is actually going to match an application performance problem. We're not really interested just in technical issues of if the round trip time goes out from 10 milliseconds to 15 milliseconds, because that's unlikely to affect application performance. But if the round trip goes out from 10 milliseconds to 200 milliseconds, that's likely to have a very significant effect on application performance. So we want to catch that and find out what was causing it. So that's my scheme for building service level objectives around paths.
Fantastic, Cliff. Thank you for answering those questions. Well, this concludes the formal part of our presentation, but Cliff will now be pleased to provide a demonstration of any specific queries relating to Neptuna to anyone who has a question. So if you'd like to stay on the line, please do so. For those who aren't able to stay, I'd just like